Alright, so for this problem, I recommend you just start by pulling out what you know you need to use. Right, we're going to grab the acetylene, so dicarbon dihydride, and the calcium hydroxide. Okay, but they are produced. That makes them the products. Okay, they're what's being produced. So these two are actually the products. Alright, and then they are made by adding water to calcium carbide. So water, we know, is H2O, and calcium carbide, they were nice to you and gave you that formula because carbon is kind of funny in that one. Alright, so we're just going to write water, which is H2O. Make sure when you're writing your chemical equations that you leave space for that coefficient. Okay, so I'm going to leave a space. I don't know if I need one yet, but in case I do. And then calcium carbide, so CaC2. And it's going to produce the acetylene, C2H2, and calcium hydroxide. Now, calcium hydroxide is one of those that throw people because it has a couple things you need to think about. First of all, calcium we know has what oxidation state? As a 2+ charge. Remember, we find it on the periodic table in group 2, and then we follow it up and we see that it's on this table. It already tells you, remember, calcium followed up, it's a 2+. Okay, so because it's a 2+, that's gonna make the hydroxide a little bit more different to deal with, because if we find hydroxide on our polyatomic table, we know it's OH with a -1. Okay, it's OH with a -1 charge. So because of that, we know that we're going to need to put parentheses around the hydroxide, because if there is a 2+ charge, it's going to take 2 hydroxides to get a net charge of 0. Okay, because it's a -1. So 2 minus 1 was a +1, so I needed to do it again and have 2 hydroxides. If you didn't have the parentheses, remember, it's only looking at the hydrogen. Exactly, and you need 2 of the whole thing. So I'm going to write calcium hydroxide with a 2 on the outside. Remember, our final formula doesn't have any charges because the net charge needs to be 0. That's the goal of an ionic compound. Alright, now we're going to balance this one. They were real nice to you because if we just eyeball it here, there's 2 hydrogens and 2 hydrogens. Okay, this has 2, there's 4 over here. Calcium, there's 1 and 1. Carbon, 2 and 2. So we know we're going to have to put a 2 out front here because I need 4 of these. And exactly, and then boom, it's all balanced because now I have 2 oxygens and 2 oxygens, and everything's balanced with that 1 coefficient. So what we end up having for coefficients, you would say, is a 2:1:1:1 ratio, because technically there are 1s here, we just don't write them. Alright, what is the molar mass of the acetylene? So we're going to take carbon, which has a mass of 12.011 grams times 2, and we get 24.022 grams of carbon. And then we're going to take hydrogen's mass of 1.008 times 2, because there's 2 of them, and we get 2.016 grams of hydrogen because it's H2. And then we're going to add those together. So 24.022, 2.016, we get 83062. What's that? Yep, grams per mole of C2H2. Exactly. Yeah, and this is grams per mole as well, yep, of H2. And grams per mole of C2. Okay, and we're just adding those together to get 26.038 grams. All right. How many grams of acetylene? So our goal is to get 2 grams of acetylene. Are produced by adding 3 moles. So if we start with 3 moles of our calcium carbide. All right, so we're going to start with our given quantity. Go ahead and try finish this to the stop sign, okay? So that's the following page. Remember, practicing until you get stuck is how you're going to get better, and I will likely post an answer key / video or something. Yep, the stop sign on the next page. So the end of Model 2.